A square sin theta del theta sigma divided by x A r sin theta del theta into x. I suppose you are getting what I have written here, right? So this will be 1 by 4 pi epsilon naught. A will go off, sin del theta will go off to give me 2 pi A sigma upon r into x. This will be. Is that clear to you, sir? Is that clear? Now, we have to use this expression to find out the total potential at the external point P. How do I do that? Let me rub this part, shall I? The total potential V at P is V is equal to 1 by 4 pi epsilon naught 2 pi A sigma constants. R is also constant because the point P is fixed at the distance R, integral dx. Now the limits we have to find, okay, from this point to this point. For the sake of understanding, if I mark this edge as x1, this edge as x2, I can integrate this between the limits x1 to x2. Am I right? Now, shall I cut this part off? Shall I? Very good. Therefore, if I integrate this, V is equal to 1 by 4 pi epsilon naught 2 pi A sigma by R. If I integrate this x, upper limit x2 minus lower limit x1. Let us go to the diagram and try to find out what is x1 and x2. Sir, if you look into the diagram carefully, from the midpoint O to the point P, the distance is r. I want x1. Therefore, r minus a will give me x1. From the figure, x1 is r minus a. Then obviously x2 will be r plus a. X2 will be r plus a. Is that okay to you? Therefore, V external. Why I am calling external? We are finding out potential at P. Therefore, V external is equal to 1 by 4 pi epsilon naught 2 pi A sigma by R, bracket open, R plus A minus R plus A. Clear? Plus or minus or will go off to give me 2A. Therefore, I will end up with 1 by 4 pi epsilon naught 4 pi A squared sigma by R. I suppose you understand what I have said, right? This is the external. This is the external. Now, sir, already I told you, surface charge density is charge upon area. Because it is a sphere, surface area of the sphere is 4 pi a squared. So, in the place of A, I can substitute 4 pi a squared. Sigma is there. Therefore, product of surface charge density into area gives me charge. Therefore, I will conveniently write this as V external is equal to Q by 4 pi epsilon naught. That is my expression for potential at an external point. Is that okay to you? That is my potential at an external point. Now, what will happen if the point P is taken somewhere inside the spherical conductor? To tell you about that, I will retain the diagram, rub this part off. Hopefully, you would have taken this, and I am sure you would have understood what I have said. Therefore, I will rub this off. Okay? Okay. For a point inside the sphere, if you take a point P somewhere here, wherever you want, okay, inside, x1 therefore, see, if you are placing this point P here at the dot where I have placed, O to P will be R. Then if I take this x1 will be A minus R. Is that okay to you? X1 will be A minus R. Then x2 will be A plus R. As simple as that. Okay? Then the same expression holds good. Therefore, I will write V internal is equal to 1 by 4 pi epsilon naught 2 pi A sigma by R bracket open x2 A plus R minus A plus R. Is that clear to you? Plus A minus A goes off to give me V internal is equal to 2R is what I get 1 by 4 pi epsilon naught 2 pi A sigma R into 2R. This R will go off to give me V internal 1 by 4 pi epsilon naught 2 to the 4 pi A sigma. What I am going to do is multiply this expression by A and divide this expression by A as well. Multiplying this expression by A, I get A squared. Dividing this expression by A, I get A. Now, it becomes very clear, 4 pi A squared sigma, previously 4 pi A squared sigma we have replaced by S cube. Therefore, I will write V internal is equal to Q by 4 pi epsilon naught A. Therefore, at an internal point, electric potential is the same all internal points. See this internal point can be here, anywhere, or even on the surface. Even if you are going to place this internal point P on the surface, at the potential is going to remain the same. So this expression tells me that the potential at point P, if it is inside this spherical conductor, will be same anywhere and will have the same value if the point P is placed on the surface of the spherical conductor as well. So this is a direct application of how to use this expression V is equal to Q upon 4 pi epsilon naught R. It's a potential detailed question, can be asked in section C, or a problem can be asked based on these final formulas. Hope you would have followed this. I have told you in detail, step by step, as to what it looked like. If you go through this video once, if you are not able to understand, please try it once again, twice, thrice, and you do it any number of times until it becomes very clear to you. Okay, sir? So we stop here today, and until we meet for the next class, I say goodbye to you. Please make notes of this and keep in touch with the subject. Otherwise, it will go haywire and you will be confused a lot if you are going to flip through all these things at the end of your semester. So I stop here. God willing, continue in the next class. Until then, goodbye.